Welcome back. We've reached the final chapter, chapter 15, which goes over factor analysis and reliability analysis. On page 169, the author Tim or Dan, he talks about how these analyses are really complicated. There's a lot of variations in them, especially factor analysis. When I was in graduate school, I took an entire class on factor analysis that lasted a semester. So really the purpose of this chapter in this video is to kind of give you an introduction to these analyses, a little bit on how to run them, and really so you can understand them better when you find them when you're reading things for your dissertation. So you have a bit of a ground basis for an understanding of them. So again, our goal is not to be experts in factor analysis, but to give you a little bit of a flavor on what it is and why it's important. So before we get started with the statistics part, I just want to give a little bit of background over why we do this and why it's important, especially in social science research, anything that's involving humans, really. So a lot of times we're interested in psychology and sociology and education. We're interested in measuring things that we can't see. So sometimes healthcare is a little bit easier because we have more concrete measures of things, things like blood pressure, glucose levels. Those things are very quantifiable. But a lot of times when we're interested in things like attitudes, those are things that we can't visibly see. So instead, we try to create questions that tap into these invisible variables. So things like personality, mood, emotion, our beliefs, etc. And it's dangerous to try to measure something with just a single question or a single survey item because there's a possibility for error. The person might misread it, they might check the wrong box because they aren't paying attention. There's a lot of room for error if you only have one shot to measure something. So instead, we use several survey items to try to measure these psychological constructs. And we call these observed versus unobserved or latent variables. Now, there are a number of ways of constructing scales and doing surveys or questionnaire research. One of the most popular is the Likert scale or summative ratings. So again, we're looking at measuring things we can't see. So things like feelings or degrees of agreement or disagreement among our survey participants. These scales generally range from about 4 to 7 points, and there are tons of articles that debate what the optimal scale length is, how many anchors you should use. And the idea is that a number of items are going to collectively measure one construct like job satisfaction. The next logical question is, how do we construct our scale? And again, you can take an entire course in this, and this probably feeds into some of the work that you do in research methods. But we want to really be careful when we're defining our construct. And to do this, we want to look to the literature. So how have people measured these constructs before? Is there a conceptual or theoretical basis for this? Are there subscales? Are there multiple items in the subscales? So there's a lot of work that's probably been done unless you're developing a brand new from scratch scale. So usually there's something in the literature that we can look to. We also want to keep in mind this idea of parsimony. So if we can measure something like job satisfaction with 5 items, that's going to be preferable than you trying to put 100 items in our survey. So generally the simplest explanation among a number of equally valid explanations is the one we want to use. And this isn't just for statistics, but really from a methodological standpoint in terms of your participants' time. So you don't want to have someone fill out a 100-question survey when you could get at the same construct with just asking 3 to 5 questions. In terms of actually constructing your survey question or your items, there are a couple different strategies you can use. Probably one of the most common are these agreement items. So things like declarative statements. So something like the death penalty should be abolished, or I like to listen to classical music. You would have a statement and then ask your participants to rate it, maybe on a 1 to 5 scale, with 1 being strongly disagree and 5 being strongly agree. And again, there's some wiggle room in terms of how those survey questions are set up. You can also ask people frequency items. So you like to read, how often, maybe every day, every week, every month, a couple times a year, never. So again, different anchors that you can use there. And then finally, there are evaluation items. So how well did your team play? How well does the police serve your surrounding community? So again, we're trying to measure these invincible things by asking lots of questions of our participants and asking them to rate these using numeric scales. Like anything in research and in statistics, we know that there are sources of error. And these are things that we want to keep in mind when we're constructing our measurement tools. So things like social desirability or giving politically correct answers, especially if you're trying to design a study to measure things like prejudice, it's really hard to create good survey items because people usually, hopefully anyways, they don't like to talk about those kind of things. So they might give answers that you think that they think you want to hear. The second one here, response sets. So this is when someone goes down and circles all sevens on something without even reading the questions, and you have no variability in that case, which is a source of error. Acquiescence is when they're telling what they think you want to hear, so kind of related to the social desirability. And then the last one is personal bias. So someone might be wanting to send a message, or they're trying to skew your data or influence it in some way, shape, or form. So there's all these rooms for error, in addition to people maybe just not paying attention. That's why sometimes when you're taking a survey, you might see in a group of positively worded questions, you might see something that's phrased in reverse or negative. And a lot of times researchers will do that to make sure people are paying attention and not just cruising down the page circling all sevens to every single item. So we know that there's error in our measurement. We know that our measurements are imperfect because again, we're trying to measure these things that we're not able to see in real life. So we do have a couple tools though that help us out in terms of determining which measures are better than others. Our first tool, and perhaps the most common that you see in journal articles, is reliability. So when we talk about reliability, we're talking about how consistent or dependent a measure is. I like to think of it as it's the same idea if you're talking about reliability of your friends. If you're asking a friend to pick you up from the airport, you want to pick one that is highly reliable because you know they're going to show up. They're going to show up consistently every single time. Now there's different types of reliability. Some of these are ones that you probably see a lot: test, retest, inter-rater reliability, and internal consistency. I want to talk a little bit about internal consistency and how it relates to designing measures and scales. So maybe there have been scales or assessments that you've taken and your result might change a lot. So I always think of kind of those fun internet quizzes or the ones from BuzzFeed. For example, I took one recently. It was supposed to tell me which Care Bear I am, if anyone remembers the Care Bears from the 80s. So I took the quiz and it told me that I was Grumpy Bear and I was really disappointed. So then I took it again the next day and I found out that I was Funshine Bear. So in that case, I don't have good reliability on that measure. It's not really measuring my Care Bear persona. It's probably tapping into a different construct, like maybe my mood for the day. So we want to be able to design measures that are reliable and that are consistent across people, across time, across different interpretations. Perhaps the most common type of reliability, like I said, is internal consistency. So again, we're talking about the degree to which our instrument items reflect the same underlying constructs. And we use Cronbach's alpha to determine this internal consistency measure. We like that because we only need to administer the test one time, unlike test-retest reliability where we need multiple administrations of it. Our Cronbach's alpha will range from 0 to 1.0, and generally the closer it is to 1, the better the reliability. And a good rule of thumb is that a reliability of 0.7 and above is considered acceptable. 0.8 is really good. 0.9 is kind of really, really good. Anything below 0.7 or even below 6 starts to get kind of questionable. But again, this will depend a great deal. It varies from field to field. So always kind of check out what's in the literature when you're reading journal articles to see what's considered acceptable or not. So I want to jump to SPSS. Before we jump into SPSS, I just want to give you a little overview of some of these variables that we're looking at, because this data set's a bit more complicated than some of the other ones we've been working with up until this point. So these items are partly based off of the data set that comes with this textbook that's available on the companion website from Tim or Dan. And oddly enough, some of this research actually relates to what I wrote my master's thesis on. So that's kind of fun, or at least it's fun for me. Hopefully it's a little fun for you. So here we have a couple of different constructs, and below each construct we have some survey questions. And you can see here that students rated all items on a 7-point scale, with higher scores indicating stronger agreement. So the first construct that we have is something called mastery goals. And this is the idea that when you're in the classroom, when students are learning, students have different goals in the classroom. So some students really want to fully absorb and understand the material. Some students just want to get their good grade. They want to look like they're smart and they want to get out of there. And other students are really concerned about looking dumb in class. They really want to avoid performing poorly. So you can see we have these three different constructs and we have questions below each of them designed to tap into those kind of imaginary constructs. So you can see in just reading them under mastery goals here, some of these questions sound similar, the wording is different, but you can kind of eyeball it and you get the sense that they're all centered around this idea of mastery in the classroom. Same thing if we look at performance approach goals. This is that idea of looking smart relative to others in the class. There's that competitive nature to it. We can scroll down a little bit and we have performance avoidance goals. So again, wanting to avoid looking like you don't know what you're doing. And then we have a couple other short scales down here. We have this idea of value that's assessed with 3 questions. This idea that the information that you learn in class is useful, interesting, and important. So again, different ways of expressing value. And we think that those 3 questions will be related in some way. And then we also have a measure of self-efficacy. So that idea that if you put your mind to it, you can do it. So we have these different constructs and we have questions to tap into each of those. So we'll go ahead and jump to SPSS now. And here I imported the data set from Microsoft Excel. So again, I just went under File, Open Data, and I pulled the Excel file, so it imported everything for me. In that case, it's a little easier than trying to copy and paste, because you can see if I scroll side to side here, I have quite a few columns of data. I have 27 variables in this data set, so that would be quite a bit to copy and paste. So I'm going to just click under variable view because I want to double check and make sure that everything imported correctly. In this case, I have a bunch of my scale questions here, and you can see it imported a lot of these as nominal. So I'm just going to go ahead and change those to scale because again, those questions are going to be things that we can take the mean of, which will help drive our statistical analyses. So we'll just go ahead and change all those to scale. If you wanted to, and if you're doing your dissertation, this might be a good practice, but under the label column, you could actually put in the text for the questions. That way you don't have to keep flipping back and forth between a Word document and your SPSS or Excel file. So it helps you keep straight which questions go along with which one. But you can see here, if I expand the name column, I just labeled the questions based on the construct. I had the number of the question, and I have W1, meaning wave 1 or beginning of the semester, because this is part of a larger data set where we measured this at multiple time points. So first we want to go ahead and we'll look at our Cronbox alpha, or how we can assess our internal consistency reliability. So to look at reliability, we'll use the Analyze menu. And we'll jump down to this one, Scale, and then you can see Scale, it drops down again, and we have a tab called Reliability Analysis. So now all we want to do is put our individual survey items, we want to transport them over. So for example, I'm just going to do this performance avoidance. So again, that was the need to kind of avoid looking dumb or feeling stupid in class. I'm going to go ahead and transport those over. And just as kind of a fun demonstration, I'm also going to throw in a self-efficacy item just for fun. You'll see what happens here. So you can see the default is Cronbox Alpha. If you drop down, there are a couple other forms of reliability that if you're interested in, you can definitely learn more about those. We can give our scale a label. So I could call this Performance Avoid Scale. If you click under statistics, there are a couple options. You can look at correlations among items. Once my window pops up here, hang on, let me fix my SPSS. There we go. So you can ask for descriptives for individual items. You can ask for the scale. This box is kind of a nice one because it'll give you descriptives for the scale if you delete certain items. So we'll just click on those for fun to see kind of what they look like. We'll just go ahead and click Continue. And then I'll go ahead and click OK. So you can see really quickly it ran our reliability for us. We had 40 cases in this data set, and you can see we have a Cronbox alpha of 0.712 with our 6 items. So that's really great. It meets our level of acceptable criteria. However, if you remember, I used the avoidance scale and then just threw in a random self-efficacy question. So that's where you always want to have a human behind this. You don't just want to kind of enter data mindlessly because there's room for error. So if we go down here to our item total statistics, you can see it's giving us the scale mean for each of those, the scale variance, and it's giving us kind of different scenarios. What would happen if you deleted certain items? So the one that we are interested in is this far right column. It says Cronbox alpha if item deleted. So if I deleted question 1 from my scale, from my set of items, my Cronbox alpha would drop to 0.656. Similarly, if I kept item 1 but deleted item 2 and kept all the other ones, my Cronbox alpha would drop to 0.59. If you look down here, you can kind of get an idea that self-efficacy doesn't really fit in, because if I delete that item, my Cronbox alpha goes way up to 0.864. So it would greatly improve the reliability of my measurement here. So that's kind of a nice feature when you're looking at reliability, because you can tell if there's a question that doesn't fit, if maybe it was confusing to the participants, maybe it was poorly worded, and SPSS can actually calculate that and tell you how to maximize the reliability of your scale. So it's kind of a cool function. I use it a ton when I'm doing research. So if you end up developing scales for your dissertation, or even if you want to look at pre-existing scales, generally you see that data reported in dissertations and in journal articles. You always want to report the reliability of your measures. So once we've determined that we have good reliability for our measurement, usually the next step is what happens is we want to create a composite scale. So we would want to create a master kind of avoidance measure out of those 5 individual survey questions. So if you're running correlation, if you're running regression, generally you don't want to run those on the individual item. You want to run it on the composite scale, because the idea is that you have that better sense of reliability because you've used multiple questions to measure the same underlying construct. So we can actually compute those pretty easily in SPSS. If we go up to transform, which is a new menu for us, we can do compute variable, and this is how we create a new variable. So I might call this overall avoidance scale. So all I want to do is I want to give my target variable a name, and then I want to tell SPSS how I'd like to calculate it. So there are a couple different schools of thought. Some people will sum or add up different scales. I prefer using the average because it accounts for missing data much more easily than if you're summing them. Again, you could teach an entire class on scale development and why you should do things a certain way. So always check with your advisor, but in this case, we'll just do it using the average. So you can see here, if you click on this function group, it has all kinds of different things that you can do to data. You can do different transformations, you can add and subtract. There's a lot you can do. So what we want to do is we want to take the average of our entire avoidance item scale. So I'm going to click on mean, and it gives me a nice definition, and all it's saying, it's kind of like Microsoft Excel. You have the mean, and then you're going to enter the array of survey questions, and it's going to compute it and create a brand new variable based on that. So I clicked mean, and I'm going to use this up arrow to transport it up here. And next I'm going to delete what's in the parentheses, and I'm just going to go ahead and transport my survey questions. I'm going to separate them with a comma. That way SPSS can read them. But I'm just going to add each of those. I won't add the self-efficacy one because we saw that that was diminishing our reliability a bit. So I have the mean of these 5 avoidance questions, and it's going to give me my overall avoidance scale. So then I'll go ahead and click OK. And you can see now on my output, it says that it computed the scale. It tells me how it did it. It executed the command. And if we go to our data set, you can see it's going to add it on at the very bottom. You can see here in our variable view, it's called overall avoidance scale. if I double click on that, it'll take me to the actual data set. So again, you can see that it computed all that for me lightning fast. So if you were doing research on this, you'd want to compute the overall scales after you check the reliability. You'd want to do that for each of your constructs and then go on to run your inferential statistics. We'll go ahead and jump back to our slides here. These are just kind of some shortcut commands for how we did our reliability analysis in SPSS. And you can see here we have some of our sample output. So you can see the reliability commands gave us a good indication that I accidentally put in a survey question that wasn't meant to fit with the other ones. We had that red flag because again, we looked at the cronbox alpha if item deleted and how that would greatly enhance our reliability in this case. However, it's not sufficient to just look at reliability when we're developing measurement scales. A lot of times when we're creating brand new measures, we want to look at factor analysis, which is a bit more in-depth in terms of how our survey questions hang together. So a little bit of a fun fact about factor analysis, it really originated with a guy named Charles Spearman, who came up with this idea that there's one underlying factor of intelligence, and he called that general intelligence, or G. So he said that if you could measure intelligence, you could select a subpopulation of people with the same score, and you wouldn't find any correlations among any tests of mental ability. So in other words, intelligence is the only factor common to all those measures. So he actually turned out to be wrong because we know today that intelligence is multifaceted. So there's verbal intelligence, mathematical, some people talk about social intelligence or emotional intelligence. So it's this idea that there are a lot of other factors rather than this giant master factor of G intelligence. So that's kind of your fun trivia on where factor analysis comes from. So the reason why we like factor analysis is, again, it's useful when we're developing scales and measurement tools. So for example, if we're going to jump back to SPSS in a minute, but we had that value scale in our data set, and these were the 3 questions we talked about. The information we learn in class is interesting, important, and useful. So we're assuming that these 3 questions are part of a larger underlying construct, this idea of value. When we're running a factor analysis, we're interested in how many different factors are needed to explain a pattern of relationships among your variables. We want to know a little bit more about the nature of those factors, how well they hang together, how well they fit, how well those factors explain the observed data, and then how much unique or random variance does each variable include. So again, getting at the idea that all of our measurement has error, but how do we create the best possible measure that minimizes that error and still gets at those underlying constructs that we're interested in. We'll go ahead and take a look at how we can run a factor analysis in SPSS. Again, your textbook goes into a great deal of detail. They talk about exploratory and confirmatory factor analysis. We're just going to dig around a little bit with the exploratory function. There's a lot of different methods and techniques. There are different softwares. Again, one time I had to take an entire semester-long class on this. So it's certainly not something that we can master in our time together, but I just want to give you a little bit of flavor in SPSS because it's actually kind of intuitive once you get into it a little bit more. So we'll go ahead, this next slide here has some of the SPSS shortcut commands, but we'll go ahead and hop over back to the same data set we were just in and look at how we might run a factor analysis. We're back to SPSS with the same data that we had before. Again, haven't done anything different to it. So let's take a look at some of these different scale items and see how we can use factor analysis to determine how well they fit together, whether they're really measuring kind of those underlying constructs they're supposed to be. So first I'm going to go to the Analyze menu, and right above our scale that we were just in, I'm going to go to Dimension Reduction and then select Factor. So here I can tell SPSS what variables we want to look at. I'm going to go ahead and use our avoidance items just as we did before. And then I'm also going to add in the value ones just for fun. You'll notice on the right hand side of this dialog box, there are a lot of options. So if you want, you can feel free to play around with some of these, but for now we're just going to click under Extraction. And you can see the default here is called principal components. So we'll go ahead and leave that default. Again, there are lots of different methods that you can use to get your factors, and your book talks a little bit about some of them, but we'll keep it simple and use the default at this point. So I'm going to ask for over here, it's going to give me what's called an unrotated factor solution. I'm also going to ask for something called a scree plot, which will be a nice kind of visualization. We'll click continue. Next, under options, I'm going to go ahead and click right here. It says sort coefficients by size. So that'll make it a little bit easier to read. You'll see in a minute what that looks like. I'm not going to mess with anything under rotation or scores or descriptives. Also, the selection variable, we don't have to do anything with that at this time. I'm just going to go ahead and click OK. And what SPSS is doing is it's analyzing those individual survey questions and participants' responses to dig out patterns to figure out which scales fit together. So you can see we have our output here. You can see we have quite a few boxes of output. If we look at this total variance explained box, you can see we're explaining about 42% of our variance with the first component, and you can see how that kind of then trickles down to the other ones. The thing that we're really interested in, if you scroll down a little bit more, we have our scree plot, and it's kind of interesting. These are infamously difficult to interpret, but the idea is that our scree plot is supposed to tell us about how many unique factors or components we have in our data. So we know, because I already plugged in the names of our variables, we should have an avoidance scale measure and we should have a values measure scale. So we should have two components, and you can see with our scree plot how we have this sharp drop from 1 to 2, and then our data kind of plateau out. So that's usually giving us an indication of how many underlying factors we have. The way that we quantify that, though, is down here with this tiny little box called the component matrix. So our component matrix has our factor loadings. And on page 171 in your book, it talks about factor loadings. It tells you that these typically range from -1 to +1. And again, the closer it is to 1, the stronger that the item is loading on that factor. So you can see that if we double click on this, we have our first component, we have our avoidance measures. This one's 0.888, we have 0.857. All of these are in the 0.8 range, which are pretty strong factor loadings. You can see here our next avoidant one is about at a 0.6, so it's lower than those other ones, but look at how different it is from these that are negative. And you can see here, if we jump over to component 2, these are very small factor loadings, and now in their values ones, we have those higher values, the 0.8, the 0.6. So the idea is that by looking at this component matrix and looking at the factor loadings, you can tell which items on your scale will go together. And now we kind of knew it would turn out this way, again, because these are pre-developed scales, and we kind of had an idea that they're meant to go together. But it's kind of a nice way of double checking your data. So it looks like this avoidance 1 item, it's maybe not fitting as great as some of the other ones. So if you were trying to make your survey shorter, or if you were concerned about the interpretation of that item from your participants, you might consider dropping that if you were to replicate your study or run your survey again. Sometimes you'll see what's called cross loadings. So if this item loaded highly on component 1 and component 2, that might be more evidence for maybe dropping the item. It might be confusing to the participants, or maybe it's measuring both avoidance and value, and it's not a well-written question. So the component matrix is really the interesting one that we want to look at with our factor analysis. If we jump back to our slides here, you can see that I've highlighted the component matrix, so you can see kind of where we have those breaks in factors. So you'll often see this in journal articles when people are developing new scales, or they're trying to replicate something with a really well-known scale, or they're trying to build on existing research. So really something that you'll see in the literature. If it's something that you want to do for your dissertation, if you're interested in developing a measurement, it's a lot of fun. I've done it before. It's just a lot of work, so be aware of that. So your book goes into some more detail that we won't get to in this video, but I definitely encourage you if it's something that you're interested in. There's plenty of great resources out there to do more reading and learn more about it. It's a really useful skill when you're doing research.